gloves, it'll hurt badly. But this edge notcher is very nice. Again, you have to lay out the corners. So if you think about making a box, you got to cut the corners out, obviously, to bend up the edges. So you can lay this out, and then this guy comes down, and we're right on the edge of the specs that we can do. Obviously, I didn't lay anything out, which is bad. So let's say we have something like this. On the shear, again, this is the thickest material we can cut on here. There's a chart on it. For those of you in CAD 3D, I also listed it there. A 16th is the thickest, 60 thousandths. We do have some stainless steel, some thinner materials. Okay, stainless is a much tougher material, so it's going to be 40 thousandths, but still very workable, very rigid, especially if you add bends in the corners to make it stronger and stiffer. If you do need to cut anything, there's a scale here on the side. You want to make sure that you use it, push it up against the edge to have it perpendicular to the cutting edge. You can move it in, scribe it, or use this to cut this piece to a certain length. So you want to go to 7 inches. And then this guy is only air, so it's not hydraulics. So it struggles a little bit to cut this, but it will cut it if you just keep your foot down on it. When you put it in, there's a guard on here. Don't try to shove anything in there to hold things. If the piece gets too short, get a new bigger piece and cut things off that you need. This is going to come down, clamp it and hold it. So once you're in position, you can let go of it. And like I said, give it a moment. Give it a moment. If it doesn't cut it the first try, hold it.
Third time's
yeah. There she goes. I used to adjust for the different height of the sheet metal. So this should be set for the thicker material, the 60 thousandths. If not, you simply turn it, then adjust the thickness. You lay it in here.
Is there some kind of scale?
No scale, no. If you get the 90 degrees, you just have to eyeball it. So once you have the part laid in here, you come down, then you have to clamp it down with this locking mechanism, and all you do then is lift this up to bend it, and there you just have to eyeball it, bring it to about 90, and bring it back down. To release it, you kind of hit the locking mechanism down here, and we'll bring it up. Okay, so once you have something like this, you want to bend up these edges. You can try to go on the left and right hand side of this guy.
I just say something. It's real easy to bend more. You bend too much and you're in trouble. So always err on the side of being 85 degrees.
Yep.
Take the fingers off too.
Well, and that's, I was gonna get there. So you have to, when you design your part, if you have something really narrow like a channel, it's almost impossible to make it on here because of the tooling we have. The backside of it would smash down on the top of this. So we can't take these fingers out to bend something up that's in the middle. It gives you some clearance, but the legs can't be higher than I think 3 inches or 4. You have to measure that. If you're trying to make something really deep, we have to have a different way to do it. This should still work. We should have enough clearance back here. You can bring it down. And then you get your whatever device you need, and this is very, very rigid, very, very solid. You can use this to build just about anything as far as sensor mounts, guards or guides on your conveyors. And if I'm tooling, mounting, sheet metal is a great tool to do those things with, rather than trying to take a block of aluminum and machine it in 2 or 3 sides, drill and tap holes in it. That gets more work than it needs to be, and also gets heavier most often than not. Okay.